All right. Nate, can you read us the objective, please?
I can simplify exponential expressions using the division property.
And tell your neighbor, what is our concept for today? Yeah, so we're still on exponential expressions. So we don't need a Fourier model because we already know what exponential expressions are. But copy the objective at the bottom left of your notes. So please do not make one of these Fourier models, please. So quick recap. We know what exponential expressions are. We said that they are numerical or variable expressions raised to a power greater than 1. Remember that? Yes, Mr. Q, we love these. Good. And then we have examples, non-examples. And you came up with some hashtags by yourself, right? And I also went over some steps. We started with quotient of powers. Remember that? And today we're going to finish up with power of quotients, okay? And, of course, we need to use the appropriate property, but at the end we also need to simplify as much as we can, okay? So with that said, like I said, we went over quotient of powers. We did some of the examples like these. We can apply them to word problems. And I want you to write on your paper, power of quotient property. Power of quotient property. Example Q. Power of quotient property. So what was the property yesterday? Quotient of power property. Today is power of quotient property. So let me get started. Here we go. Writing utensils down, look up to the screen. Here it goes. Yesterday, I gave you something like this. Look up, please. Don't copy this. Just pay attention. Here it goes. I gave you something like this. Oh, I didn't use parentheses. I did 3 to the 6th over 3 to the 4th. Something like that, right? And we can use the property called quotient of powers property, right? And why was it called quotient of powers? Because quotient means division. Powers means exponential expressions. So division of exponential expressions, okay? But today, the property is called power of quotient property. So look what's going to happen. For power of quotient, we do this. Now we can use the property for power of quotient. Now let me show you what the property does. Writing utensils down, pay attention. Here it goes. Let me show you another. Parenthesis, 2 to the 3rd over 3 to the 4th. Give me a number. 7. So this becomes we got it? Okay, tell your neighbor what's going on. Okay, copy that, please. All right, so now that we shared what the rule does, I want you to look at the definition that we wrote yesterday for the quotient of powers property. Look at the definition that you wrote down for quotient of powers property from yesterday. Look at the notes. Read it to yourself. Because I want you to look at the structure of that definition, and I want you to think of a definition for today's, I'm sorry? The day before yesterday, sorry. quotient of powers property, look at that definition, and think about the structure and how the definition should sound for this one. Everybody got it? Good, and I see a lot of you very organized. You're like, oh, let me get my phone. My app, find my notes. My goodness. Imagine, I would become a millionaire. App, do my home plate. Bam. App, clean my room. Bam. Anyways, tell you now the definition that you would use for power of quotient property. Power of quotient property. All right. I heard a lot of good conversations. Let's see. Asterisk, heart. Oh. All right. Who can get us started? Let's see. Who haven't I picked in a while? Nate, who haven't I picked in a while? Leslie, get us started, please. When dividing exponential expressions, oh, that's a good start. Pass it to someone. All right, so watch. Leslie just gave us when dividing exponential expression, which is what's happening inside of the parentheses. Do we have exponential expressions dividing here? Also here, okay? So I need someone to give me, oh, Pauline's going to give me the next part. What's happening now? When dividing exponential expressions, and I'll help you with and. Bam. Okay, when dividing exponential expressions, and what? Okay. Help her out, Kylene. Okay, that would have been good, like if it was only this one. But look, are these bases the same? Okay, let me get someone else that I haven't called. How about Nate? Yes, they're not the same. Daniel? Okay. Jaden? And there are exponents outside the parenthesis. Okay, so now we explain the situation. Exponential expressions dividing with an exponent outside the parentheses, comma, pat someone. Kelsey, what do we do? You multiply okay, let me see. Hold on. Before we write that last part. So you multiply all the exponents. So let's say somebody walks in that is not from Algebra 1, and they read the instructions. So let's look at this. Look at this one. What do you think they're going to do with the exponents here? 3 times 4 is 12 times 7, that's You see what I'm saying? So how can we elaborate that a little bit? You multiply. Very good. Write that down. You multiply the exponents inside the parenthesis by the exponents outside 10q. That sounds pretty good. You guys can help me like write books or something. Pretty good, right? All right. So any questions on how the power of quotient property works? We got this, yes? All right, so now check this out. But still, there's going to be some of you, when you're doing this work by yourself, and you come up with an answer like this, you're going to be like, I don't know if that's right. And what did we say? When in doubt. So let's see. Let's factor out. Let's look at the numerator. 3 to the 6, how many times am I going to repeat that? 5 times. So this is 3 to the 6 times 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 3 to the 6. Are these the same base? Yes. 6 plus 6 plus 6 plus 6 plus 6, 30. Oh, it works. Bam. 3 to the 4th times 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 3 to the 4th. Same base? Yes. 4 plus 4 plus 4 plus 4 plus 4, 20, and it works. Now, that's which one? Power of quotient property, what we just did up to right here. However, would you leave your answer like this? No. What would we use? What other property do we use at this point? Quotient of powers. So what would be the simplification for this, everyone? 3 to the 10. Write that down, please, and copy this so you can have it as reference. When in doubt, factor out. All right? Let's do some practice problems. Here we go. No, that's too easy. Copy this one. Example 4B. 4B. Example 4B is simplify, parenthesis, 3d squared over EF, close parenthesis, to the 4th power. I'll give you a head start for that one. See how you do. Go. Okay, let's see. What'd you get for this one, Christopher?
For the numerators, I got 81 and D8.
81 and D8 for the numerator.
And denominators, I got E4 and F4.
E to the 4th, F to the 4th. Hands if you got that. That is correct. Here goes the process for those of you that didn't get there. Here it goes. First thing you should have done is put a 1 on everything without an exponent. On the 3, on the E, and on the F. If you did not put it on the 3, that's why you wrote here 3 instead of 81. So be careful with that. So if you distribute, this becomes 3 to the 4th, D to the 8th, over E to the 4th, F to the 4th. But what is 3 to the 4th? 3 times 3 times 3 times 3, which is what? 81, and the rest is the same. You got this? Yes? All right, let's do another one. Example 4Q. Parent, 5x over y to the 3rd, z to the, give me a number, 5, close parentheses, to the 2nd. See how you do with that? Ready, go. 30 seconds. Okay. Alexander, what'd you get?
25x over y to 6 and z 10. 25x
Tw-
times x to the second power.
to the second power. Hands, have you got that? That is correct. Okay, let's kick it up a notch. Yes? Copy this one. 4C. Example 4C says simplify, parenthesis, 2x cubed in the numerator. Denominator, open up a parentheses, xy, close parentheses, cubed, close parentheses, big parentheses, and squared. We're going to do this one together. Here it goes. First things first, what do? Everyone. Put a 1 on anything that does not have one. That one, and that one. Okay, here it is. Second thing, check this out. Before you distribute the exponent outside, inside, I want you to get rid of any parentheses that are inside first. Let's do that first. So what do we do here? Tell your neighbor, please. So the denominator became what? X cubed, y cubed. Are we there? We bring over whatever we have on the numerator, 2 to the first, x to the third, big paren, to the second power, and you should be able to finish that, yes? Finish it up, please. Go. Maria, what'd you get for this one? Right here? Under? Oh, okay. X to the 6, y to the 6. Hands if you did up to right there. You should have that, right? However, aren't these the same base? So what is 6 minus 6? X to the 0. What is any number to the 0 exponent? 1. So if you did the extra step, you should have written 1 instead of x to the 0, right? Now check this out. In order to save a step, look up to the screen. Whenever you get to these and you identify that this is going to be a 1, I want you to do this. So what is 1 times 4? 4. What is 1 times y to the 6? So that's our answer. Hands if you got that by yourself. Okay, good. Let's do another one. Example 4 super Q. Big parenthesis. Fraction bar. Little parenthesis on the numerator. 3 a b to the second, close parenthesis, to the second power. Denominator, a b, close big parenthesis, to the second power. Copy that. See how you do with that one. Ready, go. Okay, should be just about done. Okay, I'm going to go through the process on this one just to make sure that everybody got it correct. Here we go. Put a 1 on everything that does not have an exponent. Yes? Do we have any parentheses inside? Yes, get rid of those. So we distribute this. We get 3 to the second, a to the second, b to the fourth, over a to the first, b to the first, and all that to the second power. Hands if you did that step. Okay? Next. Second step. Distribute, distribute, distribute. 3 to the fourth, a to the fourth, b to the eighth. Distribute, distribute. A to the second, b to the second. Hands if you did up to right there. Okay? Next. What is 3 times 3 times 3 times 3? 81. What is a to the fourth over a to the second? A to the second. What is b to the eighth over b to the second? Hands if you got that by yourself. Okay, good. Damn. That reminds me of me in kindergarten. All right. So, with that said, You're like, no, those are fairly simple, but this is what I want to get to, negative exponents, really quick. Let me elaborate on this. Writing utensils down, sit back, relax, check this out. We covered and we said that whenever you have something like this, look up please, x to the negative third, it could be rewritten as 1 over x to the positive 3. Is that correct? Okay, because we have an imaginary 1 there. We do the reciprocal inverse. Focus, please. So with that same idea, we can do that with numbers. 3 to the negative 4 becomes what? 1 over 3 to the 4th, and we can reduce that and simplify. It becomes 81. Are we there so far? But what if we encounter something like this? Are you ready? X to the negative 3 over y to the negative 4. Okay, think about it. Talk it over your neighbor and see what would you do with that situation. All right, let's see. So when this was by itself, we would do the reciprocal inverse, right? If we wrote this by itself, what would we do? Also the reciprocal inverse. So therefore, this one goes where? On the bottom, it turns into positive. How about this one? On the top, and it turns into a positive. Everybody see that? Yeah, because it does the reciprocal inverse. Okay, let's do one. Let's see. Example, Michael Jordan Q. Here we go. Let's start slow. Let's start with a to the second, b to the negative 3 over x to the negative 4, y to the, give me a number, 8. Okay, see what will you do in that situation? Go. All right, check with the neighbor, see what they got. All right, what'd you get for this one, Jaylene? X to the 4th power, y to the 8th power. Close. Let's look at it closely. Which one of these have negative exponents? B and X. Therefore, which are the only ones that we're going to move? The B and the X. So therefore, this should be A squared X to the 4th over B cubed Y to the 8th. Hands if you got that. Okay? Let's do one more. Here we go. We're getting there. Example, Power Rangers Q. Let's try, oh, here goes a little curveball. Negative 2, x to the negative 3, y to the 5th, z to the negative 2, over a, b to the negative 7, c. Let's see how you do. All right, here it goes. Answer. Is this an exponent? No, it stays in the numerator. Which ones only have negative exponents? The x, the z, and the b. Therefore, b goes on top, and it's b to the 7th, y to the 5th. Denominator, we have a, x to the 3rd, z, oh, sorry, I skipped c. to the second. Hands if you got that. That is correct. So for home plate tonight, you have your play sheet on the side that's 7-2, only do the odds. And on the side that's 7-1, I only want you to do numbers 15 through 20, which is only the geometry problems, the 6 geometry problems. Good one, guys. Enjoy your home play. See you guys tonight for open house. If not, see you guys tomorrow. Bye.